A little jive talking. I miss just talking. We have jive texting, we have jive Facebooking and tweeting. Let's just talk a little bit. Welcome to one of my favorite cities, San Diego, California. I love this place. Average temperature is 72 degrees year-round. How can you beat it, right? To kick off my presentation, I created a short video for you guys to watch, kind of give you an idea about just how important training is and a little tidbit of information for you. So enjoy that, and I'll be back.
Come and listen to my story about a man named Fred, a network engineer in over his head. And then one day he was working on the LAN, and up through the router came a hacker from the WAN. Bad news. This means trouble. Well, the first thing you know, old Fred is really scared. The Twitter folks said, "Fred, get away from there. 802 training is the place you ought to be." So he loaded up the truck and he headed for the Springs. Colorado, that is. Great skiing and legal weed. So he loaded up the truck and he headed for the Springs.
What, wires? I'm using wireless.
I hope you enjoyed that short tidbit of information. I did a costume change. I feel like Cher. So that was based on the Beverly Hillbillies theme song. And I know I lost about 50% of the crowd probably with that. But that's okay. A TV show from the 60s, right? And that's because I don't know. I'm getting a little bit older, right? I guess I should say a lot of the more senior people in the room would remember that TV show, right? So get a little bit older, and that's okay. It helps show experience, I guess is the best way of saying it. So a lot of millennials in the room that probably don't remember that TV show. Probably a good number of you are millennials. And I'm not a millennial, I'm a perennial. People think I'm dead, but I show up once a year. Anyways, again, part of getting old. And I think some of you guys remember a guy named, I guess let me back up. You know you're getting old when you see Henry Winkler doing reverse mortgage commercials. You remember Henry Winkler from the TV show Happy Days in the 70s? Leather jacket, good-looking guy, big motorcycle. I just couldn't fit the motorcycle on stage. Remember, E. Now it's A? That's okay. I can make fun of old people because I'm getting old. Going to be 60 years old next year. Couldn't believe it. I know a lot of you are thinking, he don't look a day over 59 and a half. I ran into a friend of mine about 6 months ago, and he said, I told him I was going to be 60 next year. He said, that's a milestone. I said, really, a milestone? I think it's more like a gallstone or two. So I tried my hardest to be young at heart by the way I dress. Okay, maybe not 100%. the music I listen to. Gonna go see Lady Gaga in a few months. I'm excited about that. Went to see Pitbull. My wife actually bought me tickets to see Pitbull for my birthday last year. And that was a nice treat. But the little hidden agenda there is my wife's birthday is the same day as mine. So I'm wondering if Pitbull was really, yeah, I heard a few ahs, that's cute. That's cute, yeah, for the first 2 years. After that, it gets kind of old. But, yeah, so I think it was kind of hidden agenda there where basically that was for both of us, to be honest with you. But it was a good show, and I had a good time. Anyways, so let's go ahead and get started on what you guys are here for, which is to learn about the wired side of wireless networking. Thank you for that, Gaga. All right, like Tom said, the title of this presentation is What Wires I'm Using Wireless. And that's an important thing to understand because even though we use wireless, so many of us are here for wireless, that wired is still a part of our lives for the most part. This is a poster, a marketing poster from CWNP advertising the Wi-Fi Truck Conference. And I actually have this poster hanging on my wall. And I'm thinking, who is this? Who is this kid in this picture? Well, this kid was me. I remember working with wires for many, many years prior to becoming involved with wireless technology back in early 2000 time. So Novell NetWare, Microsoft, Cisco, CompTIA, so much of it was based on wired. Now, since 1997, when the amendment to when the standard first got ratified, it's just been growing phenomenally over the past 20 years for the most part. I remember, and this was mentioned early on, Tom mentioned this in the keynote address this week, I attended the very first CWNA class that ever ran back in 2001. And that was taught by Mr. Devin Aiken, CWNA number 1. And when I sat that class, I thought, wow, this is just awesome stuff. Because it took something that I was so familiar with, which was wired networking, and tied it with another type of technology, radio frequency. So joining those two technologies together was just the perfect fit for somebody like me. It kind of reminded me of my engineering days when I was a test engineer, to be able to now apply this to something that I started to become in love with, that I've been training on networking since the early 1990s, and to be able to now utilize that type of knowledge and education to work with the wireless side. But when you think about it, this picture is really everybody in this room. That's why we're here. We're here because we want to work with a technology that is exciting, constantly changing, making you have to work to be updated and stay up to date with the current trends and the current technologies, and that's what makes it a lot of fun. So I think it's fair to say everybody here, for the most part, is this kid, or was this kid at one time. Let's go ahead and quick look at the topics I want to discuss. Remember, this is about how wires work with wireless. Power over Ethernet, a very, very important topic. It was always intriguing to me to think about how I can take this low voltage cable, put DC voltage on it, and supply power to a device to make it operate. without having to plug something into an AC outlet. Then we have the networking services, things that you're familiar with, such as DHCP, something that's going to allocate IP addresses. Remember, wireless LAN technology works at layers 1 and 2 of the OSI model, right? IP doesn't exist in my world. Well, it does exist, but from a wireless technology perspective, yes, we use all 7 layers of the OSI model, but the technology itself operates at layers 1 and 2. So IP addressing is a very important part of this whole process. Domain name system, IP address to name resolution. We'll talk a little bit about that. And finally, quality of service as well. Quality of service, something that was not part of the 802.11 standard originally, but became part of the standard with 802.11e, and of course the Wi-Fi certification, Wi-Fi multimedia. Finally, wireless design and the wired side. People forget about the fact that we have to think about the wired side when it comes to a wireless design. And we'll take a look more at that in a little bit. So let's start off with power over Ethernet. 3 things to consider, in my opinion. Number 1 is the equipment. We have equipment that supplies the DC voltage, and we have equipment that receives the DC voltage. Secondly, the numbers that are there. We have a certain amount of budget we can work with. We have to know how much power devices draw. We have to make sure we have enough AC power coming in to provide the DC power to power these devices. And finally, the design concepts. So when I teach a class, when we get to power over Ethernet, I tell people, hey, this is Ethernet technology, right? It's not wireless technology, but we use it so much with the wireless technology. And with PoE, it's all about numbers and design. Personally, I would rather see it called voltage over Ethernet. The reason why I say that is because when we talk about power with wireless LAN technology, so much of it is radio frequency power, which is a whole different ballgame. So let's talk about the equipment to start off with. The power source equipment. That's what provides the power. We'll get into that more in just a second. The power device. That is what draws the power. That's what takes the power. And power devices are more than just access points. We think about it being access points because that's what we're using it for so much in wireless LAN technology. But there's a lot more to it than just that. The power source equipment provides the power. That would be what I consider the giver for the most part. It's going to give the devices the power that they need, or, like I said, DC voltage. We have different types of power sources. And by the way, the power source abbreviation would be PSE. We have different types of power sources. That's going to be the endpoint, which comes right out of the Ethernet switch, right out of the wireless LAN controller. And we have the midspan, which would be a single port ejector or a multiple port power injector. So depending on the scale of your network would determine which of these you would be able to use. Now keep in mind the lower item there, the midspan, is the one that you see is a single port power injector. So that one device has 2 ports, which basically one goes to the device you're powering and the other one goes to the Ethernet network. That's great for a couple of access points or a couple of devices. If you cannot provide power out of the endpoint for whatever reason, you don't have the right switches to do it, the budget's not there, the midspan is a good alternative for that. However, If you have 500 access points, don't use 500 of those midspan injectors. I've seen that before too. Not a little bit of exaggeration there, right? You want to make sure that you use the adequate solution for what you're trying to provide. So the midspan is good for a small number of devices. Notice that device has 2 Ethernet ports, and it also has an AC adapter. So you plug the AC adapter into an AC outlet, and that's going to inject the voltage into the Ethernet cable. The endpoint is obviously the ideal way to go, but in some cases, just not going to work out for you. So therefore, the midspan is a good alternative solution. A multi-port midspan injector would give you many ports with one AC adapter that you plug into the wall, and it's going to provide DC voltage to all the devices you plug in. So if you have a 24-port midspan injector, 12 of those would be able to power devices. The other 12 would have to go to the network. And so, like I said, that's a good alternative in the event that you do not have any way to provide endpoint type of power. The power device, this is what receives the power. I like to call it the taker. So the power source is the giver, the power device is the taker. And like I said before, it's more than just an access point. There are many types of devices that are PoE capable out there. Voice over IP phones, for example, will be power over Ethernet capable. Clocks. I mean, the list goes on. I'm just showing it a few things there. Cameras. There's a term that really irritates me sometime, and that term is wireless security camera. I'm okay with wireless camera. I just don't like the word security in there. A jammer would make that wireless security camera just a hunk of metal hanging on the wall when you think about it, right? So kind of keep that in mind. There is sometimes limitations as to where you can use wireless technology. And finally, something that is always intriguing me, door locks. Door locks can also be PoE. Again, these are just a limited amount of solutions out there or of products that actually use power over Ethernet. Next thing I like to talk about is the numbers. Numbers are very, very important when it comes to power over Ethernet. Making sure that we have enough power budget to supply the power. Making sure we have enough AC power coming in to supply the DC power to power the devices. So numbers are key when it comes to this type of technology. Think about all the PoE devices you have. So think about this. I remember doing a wireless survey, wireless design at a school one time. I believe it was an elementary school. Typical 15, 20 classrooms, L-shape. I don't know, 15 years ago they put in Ethernet to be able to supply Ethernet connectivity to the classrooms. Their IDF was the janitor's closet. I'm sure some of you have seen that before, right? One AC outlet, 110 volts, 15 amp circuit. That's going to be important when you think about the power budget. The power budget, making sure that we have enough AC power coming in to give us enough DC power to be able to adequately supply that voltage to all the wired devices that require the PoE. There's nothing worse than running out of DC power. This happens. I've seen it happen. It's not pretty. Making sure there's enough power based on all the devices you're going to use. This is very, very important. And this requires a little bit of arithmetic. It's not calculus. It's pretty straightforward. It's pretty much arithmetic. for the most part. And we'll get more to that a little bit later on. So 802.11 technology, as you know, uses power Ethernet devices to be able to supply power to access points. The first PoE amendment came out in early 2003. It was 802.3 AF. The second one got ratified the same day as 802.11n, which was in September 11th in 2009. And that's because that was kind of the whole point behind 802.3 AT, also known as PoE+, to be able to supply enough power for the technology as it advanced. 802.11n requires MIMO, multiple radio chains, making sure that there's going to be enough power to supply the right amount of power to those devices. The power source, we talked about that a little bit ago, the power source equipment, will supply 15.4 watts of power per port. 802.3 AT provides 30 watts of power per port. It's actually capable of 60, but we're currently using no more than 30. So this is the power source that's providing that DC voltage to the actual devices. The power device is the one that's going to draw that power. And the power device can draw from 802.3 AF 12.95 watts of power versus 802.3 AT 25.5 watts of power. And the reason is because we have to think about the line loss. And we'll talk more about the line loss when it comes to Ethernet with lengths and things like that shortly. The nominal voltage for PoE is 48 volts DC. So these numbers will be important when it comes to calculating how much power you're going to actually need. And again, that's going to be the power budget. Very, very important piece here. You must know and understand the power budget. If you don't understand the power budget, there's a good possibility you could run out of DC power. And that, like I said, that is not a good thing. So many years ago, I was in a community college class or JC, I can't remember what it was. And it was like a basic algebra review session or something like that. And it was one of those big rooms that holds like 300 people, like a theater-style room. And the professor would walk into the room from a side door, and there was a platform up there, sort of like this. And they had an overhead projector. Now, again, I told you, that's what some of the more senior people in the room would remember. Overhead projector, you would put a plastic slide on, and then you would take it off and put another plastic slide on. In fact, when I first started teaching 25 years ago, that's what we used for the most part. And he walks in one day, a typical 50-minute class. He walks in one day, and he puts a slide up that says this. And he reads it. The opposite of B plus or minus the square root of B squared minus 4AC divided by 2A. And I spelled A like A, like DeFonzier. And he had it spelled as long as he possibly could. And he pulled it off the screen. And he said, remember that by the end of class. And we're like, dude, you're crazy. We can't remember that paragraph. We're still hungover from last night. Maybe it was college. So he does his little presentation. He does his spiel. And he gets up there at the end of the class that day. And he said, how many of you remember that paragraph that I put up? And we're like, no way, man. You're crazy. He said, it's easy. Just think of a picture. And that he drew that picture. The opposite of B plus or minus the square root of B squared minus 4AC divided by 2A. And for you mathematicians in the room, you know that is the quadratic equation. And the reason why I bring that up is because I remember to this day because of what he did. And the reason why I'm leading this into is the fact that we have to understand certain types of formulas with this technology, whether it be power over Ethernet, whether it be determining how much power we need to use, whether it be free space path loss, whether it be Fresnel zone. But the good news is you don't have to memorize those formulas. Because like Newton said, why remember something when you could just look it up in a book, right? I like that philosophy. So Ohm's law is one of those formulas. P equals E times I, right? That's basically what it is. Basic arithmetic. To determine how much power your devices are drawing, take the voltage, nominal voltage I talked about, 48 volts DC, times it by the amount of current it draws. So this would be an example of maybe an early 811 2.4 gigahertz access point, drawing 250 milliamps of power, times that by 48 volts DC, and you have 12 watts. Basic arithmetic. It's not hard at all. That's going to allow you to be able to determine how much power your devices are drawing and then perform the appropriate calculations to make sure you're going to have enough power. Design concepts with PoE. You need to think about the Ethernet capacity. Are there enough ports to do what you're going to do? Like I said, so you go to the school that I was talking about earlier, where the janitor closet is now the IDF, and they have a 12-port Ethernet switch in there, and they decide to want to roll out access points, roll out voice over IP phones, and put in wired security cameras, making sure that there's enough AC power to supply enough DC power for all of those devices. So are there enough ports, and is the power budget actually there? The power allocation is going to be based on a couple of things. The classification signatures. The device is going to tell the Ethernet switch or the power source how much it needs. So it's going to be classified, and it's going to say, hey, here's how much power I need, so it's going to allow that much power per port. The other thing you can do is actually manage through a managed switch, set how much power you need on each switch. On each switch port, I should say. The last thing you want to do is not have enough ports or not have enough power per port. Very important to keep that in mind. That brings me to famous quotation number 1. Famous quotation number 1. You're going to need a bigger switch. Anybody remember that one? Or it's more like, you're going to need a bigger switch. Roy Scheider as Chief Martin Brody in Jaws, 1975. What a classic movie. Nothing better than watching it on the big screen at home, on the big projection screen. After you had a couple of beers and that big shark opens his mouth. Famous quotation number 2. You're going to need a bigger switch. Me. I said it here, so it's now famous. That takes us to networking services. DHCP, Dynamic Host Configuration Protocol. We're going to see more of this come up in just a second. DNS, Domain Name System. And quality of service, QoS. So all of these services you're so familiar with the wired side, we use them extensively in wireless LAN technology. DHCP, think about so many different things. By the way, you notice my drawings, I show a LAN with 2 little lines at the end. Years ago, I had a class, and there was a young guy in my class. He was just out of college or still in college, and I drew a picture similar to this. He said, Professor, why do you, thank you, sir. That's way above my pay grade. But he said, Professor, why do you draw those lines at the end of your LAN? And I said, that's because I'm really, really old. And he had a puzzled look on his face. And I said, when I was your age, we made LANs out of Ethernet cable. And those are 50 ohm, we made LANs out of coaxial cable. And those are 50 ohm terminators at the end of that coaxial cable. I know some of you remember those. Good old 10 base 2. So DHCP, so many things we need to think about. The IP address scope. That's basically also known as the IP address pool. You need to think about the IP address lease time. Is it 8 hours? Is it 3 days? Is it 20 minutes? That lease time is very, very important because when an IP address renews, it's going to try to renew at 50% of the lease time. So think about that lease or that renew. From the wireless side, it has to go to the access point. The access point has to send to the DHCP server. And then you have a series of frame exchanges between those two devices. That takes airtime. Does anybody in here have really large venues like high-density stadiums or anything like that? What is you know what your lease time is, just out of curiosity? Sorry? 4 hours? Okay. And that's probably because of the venue. They're going to be there for no more than 4 hours. So at 2 hours, it's going to try and renew that address. At 2 hours, it's going to send a renew message to be able to get that IP address. Think about the traffic on the wireless side that's causing that. If you have too long of a lease, there's a possibility of running IP addresses. That's why the scope is important, as well as the lease time. If you run out of IP addresses, now you have IP address depletion. That's not a good thing. Important to keep in mind. DHCP server availability. If it can't renew the IP address, it's going to cut that 50% renew time by half. And it'll keep on doing that until it can finally get the IP address. So IP address availability is very, very important. And also, we can supply DHCP options, default gateway, DNS information, etc. You can also use DHCP options for devices to find for access points to find wireless LAN controllers. Option 43, option 60. So these are options that you supply with IP in order for those devices to be able to get that information when they pull the IP address. Domain name system, DNS. IP address to name resolution. Some of you probably remember that's nothing but a big host file, right? A host file is a text file somewhere on your hard drive that you would supply a name to a number. So you type in www.whatever.com, and it's going to go and resolve that IP address and pull the information from the internet. DNS automated this process. Makes it much easier to be able to allow us to do the name resolution. And DNS is an alternate to locating wireless LAN controllers from the access point perspective. So an AP, if it's not going to use DHCP, can also use DNS to locate the controller to be able to get the connection. Quality of service. Quality of service, again, was not part of the original 802.11 standard. It became, in 2005, 802.11e provided that. Wi-Fi multimedia by the Wi-Fi Alliance. I like to say quality of service on the wireless side is fairly easy. Yeah, you might have to tweak some things, but for the most part, you enable it and it's going to work well. But it's not just the wireless side. The wireless sides give us things like user priorities and access categories based on the Wi-Fi multimedia certification. So access categories, background for stuff that's not all that important, best effort, stuff that could be QoS aware, video for real-time video applications, and voice for voice over wireless IP. But this is just part of QoS. You need to think about QoS on the wired side. You need to think about the end-to-end type of QoS connectivity. And that's an important piece. Some of you may do everything, may do wireless and wired type of networking capabilities in your job. And so you understand both of these. Some of you that focus on wireless may understand the wireless part of it. Some of you that focus on wired understand the wired part of it. So sometimes there's a communication between the different divisions or different groups to be able to get this to work. Design, wireless design on the wired side. Wireless design, RF site survey, the term can be used synonymously, also includes a wired survey. That's something that's important to understand. You need to do a wired survey of the network as part of your wireless design. I like to say that RF site survey is not wireless design, nor is wireless design RF site survey. Does that make sense? Wireless RF design, RF site survey is more understanding processes, procedures, and software and how to make your design. In my opinion, that's what it is. So there's a lot to the whole concept of wireless design that also includes the wired side. Wiring closet locations, that's one of them. This was actually a picture from one of the earlier CWNA course guides. And all of your wiring closets look like that. The first day, right? So making sure you know where they're at. Remember, maximum distance. And this is something that you know from a networking perspective. The maximum distance of Ethernet is 100 meters or 328 feet. That's what the standard says, the 802.3 standard. I've heard people tell me, oh, I can get 500 feet. I don't care. The standard is 100 meters, 328 feet. That's what we need to go by. Very important, especially when you're talking about PoE. As that voltage goes across the wire, it gets to be less and less voltage. Think about the cabling. Cat 5e, Cat 5, Cat 6. That's important, making sure it's terminated correctly, making sure it's installed correctly, in addition to the length. Making sure the cabling is going to be adequate for what you're trying to do. You plug an 802.11 AC access point, you have to think about the aggregate amount of throughput, right? A 4x4x4 ACAP with 4 spatial streams and an 80 megahertz wide channel using a short guard interval will give you 1,733 megabits per second. From a signaling rate perspective, remember throughput's usually about, well, let's just say it's less than that. I really can't say the numbers because it depends on so many things with 802.11 AC, or I should say with wireless. So making sure that you have the right type of cabling, Cat 3 just ain't gonna cut it with this new technology. And I'm sure some of you have come across that kind of stuff over the years too. Finally is Ethernet switch capacity. Making sure that you have enough capacity to be able to support the devices, the number of devices, as well as the amount of throughput that you're going to need from an aggregate perspective. A dual band access point, I just mentioned that AC access point, that's only on the 5 gigahertz band. Now it's a dual band access point on the 2.4 gig side. That's going to be 4x4x4 MIMO now because of AC technology, that you got new hardware. I mean, it was 3x3x3, but now we're seeing 4x4x4 out there. To be able to give you another 600 megabits. Add those together, and that's just one access point. So think about all the aggregate stuff. Boy, I'm almost out of time. I could talk about this stuff all day long, as you can imagine. Well, let me end by what you learned. Hopefully, you learned something in this short 40 minutes that we had to spend together. And I hope that what I went over kind of opened your eyes and made you think about certain things when it comes to this technology that we use and love every day. I also want to say that, as Tom mentioned, I have been part of the CWNP program for 17 years. Sat that first class from Devon, and what a great class it was. And that's what really got me into to keep on working with this technology and pursuing this technology. And it's been a pleasure to meet so many people over the years. You know, I kind of thought the past 6 months, I'm not getting any younger, you know, maybe I should just give this up and move on to something else. And kind of maybe open a bar on a beach somewhere. And then I thought, nah, I'm going to stick around for a few more years. And that's kind of what I decided to do. But to come here to this conference and to see the enthusiasm. We had almost 100 students in here in 4 different classes. To see the enthusiasm, to see Sunday morning, 8 a.m., it's football season. It's baseball playoffs. And everybody is here, and they stayed all day. They were on time. They went to lunch. They were back on time. They were here till 5, 6 o'clock every night. That's dedication. Spending 3 days listening to me. Of course, all the other classes, it wasn't too bad, right? So it was such a pleasure to be able to be part of that and to continue to be part of that. And to realize how important this program is and how important vendor-neutral LAN wireless training is to be there for us. So I hope you enjoyed it. I want to thank you. I don't have any time for questions, I'm sorry. But feel free to reach out to me. I'll be hanging around either here at the testing center. And like I said, I thought about giving it up, but when I came here, it made me realize I got to be here to help people learn about this great technology. So in the words of one of my favorite musical musicians, Elton John, I'm still standing, and I hope to see you.